Today I'm going to be talking about properties of special parallelograms, and this is day 2 of Chapter 7, Section 4. So we're once again going to review our properties of our parallelograms. These are really important because this is the base of all parallelograms, so we have to know these properties. So let's go over these once again. Our properties of our parallelograms are that opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are 180 degrees, and diagonals bisect each other. Okay, so these 5 properties apply to parallelograms and special parallelograms. So today we're going to be talking about rectangles and squares. So first off, let's talk about the properties of a rectangle. Well, a rectangle is a parallelogram, so it will have the properties of parallelograms. But there's 2 special properties that rectangles have, and the first one is that all your angles are 90 degrees. And the other one that's special about rectangles is that the diagonals are congruent to each other. Which in parallelograms, that's not true. But in rectangles, it has the properties of a parallelogram, but also those 2 diagonals are congruent to each other, and all angles are 90 degrees. All right, now before we move on to squares, we also have to remember the properties of rhombuses, because this will affect our square properties. So if we remember from yesterday, our properties of our rhombus were also the properties of parallelograms, because it is a parallelogram. And what was special about this is that the rhombus, all sides were equal or congruent. The diagonals are perpendicular. Meaning in that middle area where they intersect, you have right angles or 90-degree angles, and that diagonals bisect opposite angles, meaning at the corners, that angle is separated into 2 equal pieces or 2 equal angles. Same thing on the other corners. Those 2 angles are separated into 2 equal angles. Okay, so those are a property of our rhombuses. So now we get to squares. Squares are extremely special because they are a parallelogram, so they have the properties of parallelograms, but they also have the properties of rectangles, and they also have the properties of rhombuses. So the square has properties of everything: parallelograms, rectangles, and rhombuses. So you can apply any property to a square and it's true. So you have your right angles, you have congruent sides, your diagonals are also congruent. So basically everything is congruent to each other and you have 90-degree angles everywhere. Okay, so we're going to use all of these properties to solve for rectangles and squares, right? So the first one says find the lengths of the diagonals of the rectangle ABCD. So we're going to find the length of the diagonals. Well, what do we know about diagonals of a rectangle? Well, we know that diagonals are congruent for a rectangle. That is a property that is true for a rectangle. So if the diagonals are congruent, I give you AD and I give you BC. These are the diagonals of this rectangle, and since diagonals are congruent, we can set them equal to each other. So we can say 5 times the quantity of y minus 3 equals 3y plus 1. So we can set them equal, and now we can solve algebraically. We're going to distribute, and we get 5y minus 15 equals 3y plus 1. Subtract our 3y. 2y minus 15 equals 1. Add your 15. So 2y is equal to 16. Divide by 2, and y will equal 8. Now don't stop there, because I'm asking you to find the lengths of the diagonals. I'm not asking you to find the variable. I have to find the lengths of the diagonals. So what I have to do is I have to plug it into the diagonals. So I do 5 times 8 minus 3, which is 5 times 5, which is 25. And since the diagonals are the same, they're going to be the same length, so AD and BC are going to be the lengths of 25 and 25. So don't forget to plug back in to find the lengths of the diagonals. All right, now it says find the following measurements of rectangle ABCD given that AD is equal to 15. So let's look at that. AD is 15. This whole piece right here, it's 15. It's 15. So that's one diagonal. And they also give us that 25 degrees in the corner for CBD. Okay, so let's look at what they're looking for. I'm looking for CB. CB is the other diagonal. Well, since diagonals are congruent in rectangles, CB is going to be 15 as well, because the other diagonal was 15. All right, let's look at the next one. We're looking for CP. CP goes from here to here. Well, that's half of the diagonal, and if the whole thing is 15, we can divide 15 by 2, and we get 7.5. All right, now we're looking for the measure of angle ABC. Measure of angle ABC. So let's highlight that. Let's see where ABC is. A, B, C. Okay, so we're looking for that angle right here. Well, what do we know about angles of rectangles? Well, we know that all angles are 90 degrees. So that angle is 90 degrees. So if one piece is 25, we can subtract that piece and get 65 degrees for the other missing piece, for ABC. So that's 65 degrees. And our next one that we're looking for is ACB. So ACB. Oh, so we're looking for this. Well, if we notice, we have this right here. And since a rectangle is a parallelogram, these are alternate interior angles. And so they are congruent. So that other angle, ACB, is 25 degrees. So we used properties of rectangles and of parallelograms to solve for this. All right, let's move on to the square. Let's see what we can do with the square. So it says, find the following measurements for square ABCD. And the only measurement that I give you is that line segment AE, which is 5. And we're going to find everything else. So our first one is AC. AC, this diagonal. Well, if we know that AE is 5, then the other piece is 5. And the entire thing is going to be 10, because we're going to add them up. Let's look for BD. BD is the other diagonal, and in squares, diagonals are equal to each other. So if AC is 10, BD is also 10. Now let's look for DE. DE is this right here. And since the diagonals are equal, they're both 10, and the diagonals bisect each other, so they're equally split into 2 equal parts, so DE will equal 5. Okay? So now let's look for these angle measurements. Let's see what these angle measurements look like. So I'm looking for AED. AED. Well, this is an angle made by the diagonals, and we know that the diagonals are perpendicular, and perpendicular makes 90-degree angles. So the measurement of angle AED is 90 degrees. Let's look for angle EBC. All right, so we're looking for this piece right here. Well, in squares, we know that all angles are 90 degrees. And that those diagonals bisect those angles into 2 equal parts. So we can divide that by 2 and get 45 degrees. So this angle measurement right here is 45 degrees. Because we can use any properties of parallelograms, rectangles, or rhombuses to solve for squares. Let's do one more square problem. It says find the following variables. And if we look at this picture, we know it's a square because all the angles are 90 degrees in the sides and the angle in the middle is 90 degrees. So we know this is a square and not a rhombus. Okay? So let's solve for x first. X is on this side and this side up here, AD. Okay? It's on sides. Well, we know that squares have equal sides. So if squares have equal sides, we can say that 2x minus 6 is equal to 4. And now we can solve algebraically. We're going to add the 6, divide the 2, so x is equal to 5. So using the properties of squares. Let's look for y next. Let's look for y next. Well, where is y? Y is at this angle in the middle where the diagonals intersect. Well, we know that the diagonals are perpendicular and they make 90-degree angles. So we can say that 5y is equal to 90. So we divide by 5, and y is equal to 18. Our last one, z, let's take a look where that's at. Where is z at? Well, z is at this angle right here. Well, we know that the whole angle is 90, and then that diagonal bisects that angle into 2 equal pieces. So this half of that angle is 45. So we can set 3z plus 3 equals 45 and solve. Divide by 3. So z will equal 14. So we can use any of the properties of parallelograms, rectangles, or rhombuses to solve for squares.